Hey stats class, let's look at this example, how to do a correlation and a regression line with a spreadsheet. So we're told to find the regression equation and let chest size, the top value, be X and weight then would be Y. And we want to come up with a weight, a predicted weight, if the chest size is 44 inches. Now make sure you look, 44 is within this data set, meaning the smallest number I see here is 41, the largest number I see is 52. So 44 is within that range, so it's a value that I could safely predict. If it's outside of that range, we've got to be careful. That's called extrapolation. There's no guarantee that line, the linear pattern we get, is going to continue on. All right, let's click this button, copy this to our clipboard, Control C, and then come over here to column A, Control V. All right, so there is my chest size, my weight. Okay. What's the regression equation? So we're going to come over here, equals line EST. My Y values, again, it's telling us to use these as Y's. Don't use the word weight in there. Don't grab the column headers. X, just the numbers. I do want you to calculate the Y-intercept. I don't want those other stats, so I'm going to select 0 for verbose. All right, once again, this is your slope. It's always the first thing it gives you. This is your Y-intercept. All right, let's calculate the correlation coefficient, R. All right, select your Y's, comma, select your X's. So there's correlation. So there is significant correlation here. If I wanted to look at these critical values, I have 1, 2, 3, 4, 5, 6 data points. So that means n equals 6 here. I have to clear 0.811 for at the 0.05 level. I would have to clear 0.917 at the 0.01 level. And just barely missed that, but I'm doing it at the 0.05 level, so I do clear that number. I don't have to worry about missing that value. Okay, so I am going to use the line the best fit for my prediction. Now we'll talk about in just a second, what would happen if we were to use that one and we weren't using the line. All right, so there's my slope, the number with the, see, it says 1 decimal place. So I'm going to highlight both of these and bring them back to just a single decimal place. So this doesn't have an X, so that's the negative 170 and 0.3, and then the correlation is, the slope is 9.8. So that's the number in front of X. All right, what's the best predicted weight? The chest size is 44 inches. So I'm just going to write prediction value X. So X here is 44, and the way that we get this is we're going to multiply the value of X by the slope and then add the Y-intercept. So we multiply that number 44 times the slope and add the Y-intercept. So I just click my 44 times the 9.8 plus Y-intercept of the negative 170.3, and it gives me that number. So that's the number, round to 1 decimal place is needed, so there's the number, 0.7. Now let's just say hypothetically that it said, instead of 0.05, it said the 0.01, and I look over here and I see I need to be at 0.917 for correlation, and I'm not. I'm at 0.915. Then what I would have to do for the prediction is I would not use the line. I would not multiply by the slope and add the Y-intercept. I would just use the average of the Y values. So right here, I'm going to write average Y, and I'm going to do equals average of these numbers. And that would be my prediction if the correlation was not greater than the value it needed to be. So if the correlation is above this number, if this number with my, the line I'm on, n equals 6 here, so I'm looking at these two numbers. If they tell me to use this level for alpha, basically these numbers are what we have to clear, what correlation has to clear for us to use the line as the best predictor. If it clears it, then we use the line. We multiply by the slope, we add the Y-intercept to predict. If it doesn't clear it, we use the average value for any estimation, because when it doesn't clear it, we don't have significant correlation in the population. So that's why I would calculate that. That's my prediction if the correlation doesn't pass the correlation test. All right, now the next question here is asking, is it close? That's that 5% threshold we talked about. So we're going to take this predicted value. I'm just going to put this there. Is it close? We're going to take the predicted value. We're going to subtract the actual value, which is this 213 pounds. and we're going to divide by the actual value. Always divide by the actual number, and then times 100. And if that number is less than 5%, a percent calculation, you don't have to put this in your sheet, but that's the calculation we're doing. If that's less than 5%, then it's close. It's not less than 5%. Okay, and again, if the prediction is smaller than the actual value, if this were a negative percentage, it's still just absolute value if it's less than 5%. So just ignore the minus sign, or put absolute values around it, because technically there is in the calculation. But we ignore the sign. 23% is not below 5%. So since it's beyond that 5% threshold that we've been using for close, we would say this result is not very close to the actual weight of the bear. So that's that particular question. But the new thing that we're doing at this question, we haven't done the other ones, is this prediction, using the line or the mean for prediction. Use the line if the correlation passed the correlation test. If we clear the number that it's asking you to, use the mean if it doesn't clear that number.